Then the next topic is gaseous state. This is a simplest state of matter that throughout your life remains immersed in the ocean of air, which is a mixture of gas. See, they have different layers in our sea level. That is the lowermost layer is called for an atmosphere is called troposphere. See, which is held to the surface of the earth by the gravitational forces. See, here it shields that form of the harmful radiations like the thin layers of the thin layers of the atmosphere, that is its vital, like what is it called, there is harmful gases. So that radiations hinders, that radiations are hindered substance like some kind some substance are like dioxygen, dinitrogen, carbon dioxide, so water vapors, etc. These elements also, these compounds are also present here in a periodic table. In gaseous state, in a periodic table, we have the group wise element. The group 1 elements, hydrogen. This hydrogen exists in gaseous form. Then group this is group 1. The group 15, 16, 17 and 18 elements also gaseous form. Like group 15, the first number is nitrogen, 16 oxygen, then 17 fluorine, fluorine and chlorine, then 18 group 18 all inert gas, like noble gases are inert gas. So these are the elements are in the gaseous form. See here the gaseous states are characterized by the physical properties. That means gas molecules are highly compressible. Then the gas molecules, the pressures equals in all directions. That gases exert pressure are equally all directions. Then the gas have much lower density than the solids. See, gas means lower the density compared to solid and liquid. Then the volume and shape gases are not fixed volume and shape. Then this assume volume of a shape is the container. That means gas mix evenly or completely in all proportion without any mechanical aid. So these are the main characteristics of the physical properties of the gases. Here the next, the behavior of the gases. Some general laws are there, that is gas laws. The gas laws. Mainly this gas laws related to the pressure, temperature, volume. So mainly related to these things: pressure, temperature, volume. First we will discuss the gas law. That is first one. Gas law contains Boyle's law, Charles law, Avogadro law, Gay-Lussac's law, and the Avogadro law. So we are going to discuss these 4 laws. The first one, the Avogadro laws relationship, that is the volume amount relationship. Volume amount relationship. The Gay-Lussac's law here, the pressure temperature relationship. Pressure and temperature relationship. Then the Charles law, temperature volume relationship. Temperature volume relationship. And the Boyle's law, pressure volume relationship. So we will discuss one by one. First is Boyle's law. This scientist, the Robert Boyle, done one experiment that is based on the pressure and the volume relationship. Here he conclude one sentence, that is at constant temperature. The statement is at constant temperature the pressure of a fixed volume, the pressure of a fixed volume, that is pressure of a fixed amount, not volume, amount, fixed amount of gas varies inversely proportional to the to its volume, inversely proportional to its volume. So this is the statement of the Boyle's law. So the mathematical expression, like P is inversely proportional to, that is V. So here at constant temperature, that is here at the constant temperature and the number of moles, that is the fixed amount, so that is called the number of moles. So here we have to introduce the proportionality constant. So K1 P is equal to K1 by V. Here the K1 is the proportionality constant. The value of constant K1 depends upon the amount of gas. So depends upon the amount of gas, temperature of the gas, and the units in which the pressure and the volume is expressed. So on rearranging this equation, PV is equal to K1. It means that at constant temperature, product of pressure and volumes are fixed amount of gas is constant. So if a fixed amount of gas is constant temperature, occupying volume, that is V1, volume occupying volume V1 at pressure P1. So that's equals what becomes volume V2 and the pressure V2. So it rearranging this equation, P1 divided by V2, sorry, P2, B2 divided by B1. So this is the relationship. We can there is the two conventional ways are expressed in the graphical presentation. For example, the graphical presentation for pressure versus volume. Pressure versus volume. The pressure usually in bars at different temperatures, that is at the different temperature the value of K1 for the curve. First this one temperature, this one temperature, and this one temperature. So they are different temperatures. That means this is a 200 Kelvin, this curve for 400 Kelvin, then this is a 600 Kelvin. So the value of K1 for each curve are different because of the given mass of the gases varies only with the temperature. So that is the way each curve, that is the correspond to different constant temperature. So 200, 400, 600 Kelvin. So this is called isotherm. Iso means constant and therm means temperature. So constant temperature. This is a constant temperature plot. So the volume of the gases doubled. That means if the pressure is halved. Okay, this is the conclusion. That means the volume is 0.09 mole of carbon dioxide at 300 Kelvin. Then another one more the graphical representation we can give, that is pressure versus 1 by V volume. It gives a straight line like this. So here this is T1, T2 and T3. Here the straight line of the passing the through, or that is the high pressure of gas deviate from the Boyle's law, and under such condition the straight line is not obtained in a graph. So that experiment of the Boyle's in a quantitative manner prove that the gases are highly compressible, because when a gas of mass is compressed, so that means you can compress the gaseous molecule. So some of the number of molecules occupies in this smaller space also. That means it becomes denser at high pressure. When you pressure it, the density also increases. So the relationship can be obtained in the density and pressure of the gas using the Boyle's law. So here the density is what? D, and density related to the mass and volume, so that D is equal to m by V. Density is equal to mass by volume. Here the Boyle's law equation, the obtained relations between, that is the, we can read, that is D equal to m by K1, that is Boyle's law related to this, you will be getting K dash P. So this is the relations of the Boyle's law. So we can use it, this formula, and this formula we can solve it some numerical problem. Here that arranging that order is T3 temperature is higher, so that greater than T2, greater than T1. So this is the range. We will discuss problem also here based on the Boyle's law numericals. The problem is a balloon is filled with hydrogen at room temperature. If it will burst if pressure exceeds 0.2 bar. If at 1 bar pressure the gas occupies 2.27 liter volume, up to what volume can be the balloon be expanded? So this is the question. According to the Boyle's law, the formula is what? P1 V1 is equal to P2 V2. This is the formula. Here pressure is 1 bar, that is V1 will be what? 2.2 volume. So V1 will be 2.27 liter. Then here the P2 pressure exceeds, that means that will be P2. P2 is what? Here 0.2 bar. Then volume is V1 this and P2 is this. So now we can using of that calculation, that V2, the rearranging, first we have to find out V2. So here V1 P2 and the P1 is called 1 bar. Now the formula of rearranging of this formula, V2 is equal to what? P1 V1 divided by P2. So the P1 is what here? The P1 is 1 bar and the V1 is 2.27 liter. Then the P2 is 0.2. Using of the logarithms, using of logarithms table, you can get that this is a bar and this is also bar. This is the liter. Bar cancel. The unit will be, the final result will be 11.35 liter. So the balloon bursts at 0.2 bar pressure. The volume of balloon should be less than 11.35 volume. So this is based on the Boyle's law calculation. Next is Charles' law. Next, the Charles' law is the relation between the temperature and the volume. Here the Charles and Gay-Lussac's performed many experiments based on the gaseous gases are independently to the improve upon that hot air balloon technology. Here, some investigation that shows for a fixed mass of a gas at constant pressure, volume of a gas increasing on the increasing temperature and decreasing on cooling. So they found that the each degree rise in a temperature volume of a gas is increased by 1 by 273.15 of the original volume of the gas at the 0 degrees Celsius. So the volume of the gas at 0 degree Celsius at total degree Celsius, that is T degree Celsius, and that is V naught and Vt are respectively, that is V naught and the Vt for this the volume. So Vt is equal to the related between that V naught plus 1 that is 1 here the T. So T divided by 273.15 to V naught. So V naught, we are taking the simplification, V naught is common, and the Vt 1 plus T by 273.15 Kelvin. So the rearranging of this equation, V naught is Vt is equal to V naught to 273.15 plus T divided by 273.15. So at this case, that is the new scale of the temperature that's called T degree Celsius. The scale is given by the temperature is 273.15 plus T. That means 0 degree will be given, that is T naught is equal to 273.15. So this is called thermal scale, that is thermodynamic scale, that is called the SI unit is called Kelvin. So 273.15 Kelvin. That means 0 degree on the Celsius scale equal to 273.15 at the absolute scale. See here the degree sign is not used while the writing of the temperature, and that is absolute temperature scale, right? That you have to use the Kelvin only, not used to degree. Simply we can add 273. More precisely means that is 273.15. Usually we are adding 273 Kelvin for a 0 degree temperature. If you write that is Tt is equal to 273.15, that T, and T naught is what? 273.15. So the relationship between what? Vt is equal to V naught Tt divided by T naught. The rearranging of this equation will be getting, I am writing here, Vt divided by V naught is equal to Tt divided by T naught. Then the general equation we can write like this, that is V2 divided by V1 and T2 divided by T1. So this is initial and this is the total, that's why I am writing like this. Here this is also volume initial, volume total, so that writing like this. So V1, then rearranging of this again, V1 divided by T1, V1 divided by T1 is equal to V2 divided by T2. So Vt is equal to constant Kt. So V by T is equal to constant. The constant is usually denoted as K2. So the final equation will be, that is V is equal to K2 into T. So volume relationship, volume temperature relationship. Here the value of the constant K2 determined by the pressure of a gas. Its amount of the units which is volume is expressed. So this is called Charles law. The statement of Charles law is the pressure remaining constant, the volume of a fixed mass of a gas is directly proportional to its absolute temperature. So this is called Charles law. Charles that found that for all gas at any given pressure, graph of a volume that is versus temperature, volume versus temperature, that is in Celsius. So here that four straight lines are obtained, that is the straight line and exceeding to the zero volume. So exceeding to the zero volume. So each line intercepts of the temperature at minus 273.15 degrees Celsius. That slopes of lines obtained at the different pressure P1, P2, P3, P4. That is but the zero volumes are lines meet at the temperature axis at, see this is the meeting line, the temperature axis is minus 273.15 degree Celsius. So that each line of the volume is what each line of the volume is called volume versus temperature graph is called isobar. Constant that pressure. So sorry, iso. So constant the pressure. Then here that the value of that that given before we studied the T equation is minus 273.15 degree 15 degrees Celsius. So that the volume of gas is minus 273.15 degrees Celsius will be 0. So this means that gas will not exist. So in fact all the gas liquefied before this temperature is reached. So the lowest hypothetical or imaginary temperature at which gases are supposed to occupy zero volume is called absolute zero. So we can discuss one more problem according to the Charles law. According to the Charles law, based on this problem, on a ship sailing in a Pacific Ocean where temperature is 23.4 degrees Celsius, a balloon is filled with 2 liter air. What will be the volume of the balloon when the ship reaches Indian Ocean, where the temperature is 26.1 degree Celsius? According to the Charles law, the formula is what? That is V1 divided by T1 is equal to V2 divided by T2. So here the V1 is what? The volume of liter. So balloon filled with 2 liter. So that there is 2 liter. And that V2 we have to find out. So T1, the given is what? The T1 is 23.4. So adding of it converts to Kelvin, 23.4 plus 273. So it converts to what? It will become 296.4 Kelvin. Then T2, temperature 2, that is reaches in Indian Ocean, 26.1 plus 273. So it will become 299.1 Kelvin. So the rearranging this formula, V2 is equal to V1 T1 V1 T2 divided by T1. Now applying the value, V1 is what? 2 liter, and the T2 is what? 299.1 Kelvin divided by the T1 is what? 296.4 Kelvin. Kelvin cancel. So the remaining after simplification of this value, you will be getting that is 2 liter into 1.009. So it will become 2.018 liter. So this is the answer. The next Gaseous law, pressure temperature relationship, we will discuss later.